Let's look at the partial sum of an arithmetic progression. The same thing as an arithmetic sequence. Now, when you have the numbers just separated by commas, alright, what you have is a sequence. However, if you add them, you get what is called a series. So a plus d plus a plus 2d and so on is a series. When you add them, you get a series. So when you just have the numbers, what you get is a sequence. When you add the terms of a sequence, you say this is a series. All right. Now, our textbook on page 854 it presents a certain situation, a certain problem, and we're going to be looking at it. You want the sum, and remember uppercase sigma, Greek letter, means the sum of from k equal 1 to 100 of k. So this is really an arithmetic progression, you know, because look at this. When k is 1, it's just 1 plus k equal 1, then 2 of k, which is 2, plus in third place k, when the k is 3, so it's plus 3 plus, and so on and so forth, up to plus 98 plus 99 plus 100. All right, so this would be an actual example of an arithmetic progression where you want the sum. We say partial sum because, you know, the arithmetic progression, it doesn't have any end. It goes on and on and on. So what we have is a partial sum. We can't really add all the terms to infinity, an infinite number of terms. So we have to stop somewhere. In this case, we start at 1 and we end at 100. But how do we deal with this? Let us see. The technique here is this. If you have the sum, in the first place is 1 plus 2 plus 3 plus 4 plus 5 plus, and you go on and on to plus 98 plus 99 plus 100. So remember, this is a specific example. We're going to look at a general example later on. So this is the sum. Let's call it S100, meaning it is the sum of the first 100 terms. All right? So we call that S100. You have the terms in ascending order. It goes up from 100. Suppose you have this listed again, but you reverse it. So you have S100 is equal to, all right, you have 100 plus 99 plus 98 plus 97 plus 95, all right, and it goes right down to, so in this case, oh, I said 97 and then 95, it should be 96 here. I skipped out the 96 is 96 plus and so on. All right. So this is plus 3 plus 2 plus 1. Suppose you add the terms that are lined up one above the other. what you get. When you add this and this, you're going to get 2 of the S100. So 100 plus 1, give you 101 plus 99 plus 2, well, it's 101. Plus 98 plus 3 is 101. Plus 97 plus 4 is again 101. Plus, and you have 96 plus 5 is 101. Plus, and so on and so forth. Plus 98 plus 3 here is 101. Plus 99 plus 2 is 101. Plus 100 plus 1 is 101. Now, there are 100 of these, right? So since there are 100 101s, you say 100 times 101. That will give you what? 10100. 10,100, right? So, in this case, we have 10,100. But this is 2 times the sum of the first 100 terms. So, if we say the sum of the first 100 terms equal, you divide both sides by 2. Because remember, this is 2 of S100, right? If you divide by 2, you get the sum of 100 is 10,100 over 2, which gives you what? 5,050. All right. So that's what you have. Now, let us look at the more general term and see how you could possibly deal with that. All right. Let me fix up these things that I have here a bit. Let's erase and paste back the heading. Okay, good. So, in this case, we want the sum of the first n terms of an arithmetic progression. Now remember, the an is a plus n minus 1 times d. Now, if we're going to sum from 1 to d, we, first of all, the thing that we're going to sum up is a plus, if we write n minus 1 d, you might be tempted to write this, n equal 1 to n, but it would make sense. Because n is a fixed number, it's a number of terms. Remember, the terms are constantly changing, so we have to change the letter from n to something else. And in fact, you cannot sum, say, from n equal 1 to n. No. If n is 50, we cannot say n equal 1. So we have to use a different letter for n in this case. All right? So let us call it k equal 1 to n, to where it's going to stop. And this is k minus 1, because the first term is k equal 1, then 2, then 3, going up to n. All right? So, here now, what we have is the first term a plus, then we have the second term, but let's write it like this. Instead of writing it here, let's write it like this. This is equal to, you're going to have a plus 0d. That's for the first term. But 0d is just 0, so let's leave that out. So a plus You're going to have a plus 1d. Or we could forget about the 1. We could drop off the 1 and say a plus d plus, and then we have the next term. Remember, it's a, when k is 1, is a plus 1 minus 1d, which is 0d. Then a plus 2 minus 1d, which is a plus 1d. Then a plus 3 minus 1d, which is a plus 2d, right? Plus a plus 3d, right? But here, instead of saying a plus 2d, a plus 3d, we're going to write the number minus 1d. So we have a plus 2 minus 1d plus, then a plus 3 minus 1d plus, and so on and so forth. So remember, this is the first term, right? Second, first term, second, third, and going on and on. Plus, then a plus 4 minus 1 d plus, and we go on like that. But then we reach a point where we don't know exactly what that term position is. So we use n now. So if it was 50, just before 50 it will be 49 minus 1d, and so on. So we say plus a plus n minus 2d. Let me rewrite that. N minus 2d. You see that? Plus, I have limited space. Then the next term would be a plus n minus 1d. Alright? Now, these are all the terms that you are adding. Now remember, what we do next is to write the last term first and put it under the a. So if we repeat this using the last term first, we have a plus n minus 1d, alright, plus a plus n minus 2d plus a plus n minus 3d plus, and so on and so forth. Alright? So in this case, we go down and down until we reach the last one, would be a. The second to last one would be a plus. Let me get some space here. The second to last one would be a plus 2 minus 1 d. The third to last one would be a plus 3 minus 1 d, and so on and so forth. Alright, so let's put these things together now. Let's rewrite this thing. Alright? Or not rewrite them. Let's add them up. What we're going to do is look at these two and add them. A plus A. We have a plus n minus 1 d. You see that? Let's add these two now. plus. Now, what we have here is A plus A, this A plus this A, plus 2 minus 1 would be 1D. So we have n minus 2D plus 2 minus 1D, which is just D, plus. Alright. How do we fix up this part? A plus A, alright, n minus 2D. Let's expand the bracket here and see what we have. This A plus A would be 2A plus n minus 1D, good, plus. This would be 2A plus n minus 2D plus D, would be, in this case, multiply D by N, and D minus 2D plus D. But negative 2D plus D would be what? It would be minus D. So this part would be minus D. And when we factorize here now, put D outside the bracket, what we have is D and n minus 1. So we get n minus 1 D. You see that? So that's this part taken care of. Plus now, we're going to be adding these. This part would be A plus A. Let's just put it as 2A plus 3 minus 1D is 2D. 2D plus n minus 3D. If you open the bracket, you're going to have 2A plus 2D plus ND minus 3D. Alright? 2D minus 3D is going to be negative 1D. So we can erase the 2D and the 3D, and we get minus D. Now, if we factorize, put D outside the bracket, we're going to get D n minus 1, which is the same thing as n minus 1 D plus, and you go on and on until you reach the last part that says A plus A. It's going to be 2A plus n minus 1 D. Now, remember, all of this here is 2 times the sum of n terms, because this is the sum of the n terms and this is the sum of n terms. It's just that it turned back way. You will repeat it with the last term first. Now, here now, what you have is 2 times the sum of n terms equal. Then you have 2A plus n minus 1 D. And you notice you have 2A plus n minus 1 D repeated. You have 2A plus n minus 1 D, 2A plus n minus 1 D, 2A plus n minus 1 D. You have it repeating itself. So here you have n, the number of that is n, whatever n is. So it's 2 times the sum of the n terms equal n times 2a plus n minus 1d. So if you should divide by 2, you get the sum of the first n terms is equal to, it's really n over 2, right? Half n, which is n over 2 times 2a plus n minus 1d. So there you have the form of the sum. That's the equation for finding the sum of the first n terms of an arithmetic progression. N over 2, 2a plus n minus 1d. Right? So that's the formula. So what we're going to do next time is look at some examples where we sum the first n terms of an arithmetic progression. So I'll see you then.